The goal today is to go through the features of the WisGate Connect. The slides, the script of the slides is made just an excuse to talk about the different features and capabilities of the board. But as Michelle said, if you have any questions at any moment, just interrupt me and we will go more in detail about that specific question. I will try to do it in about 45 minutes and leave some room for this Q&A part at the end or during the talk. I would also like to do some hands-on thing, especially how to deploy services in an easy way. But yeah, let's see how it goes and what time to do it. So the WisGate Connect, I guess you already know about the WisGate Connect. Like I said, the goal is to go through the features, hardware compatibility, and assembly, and also talk a little bit about the OS, RAKwireless we suggest to use with the WisGate Connect, and welcome any questions you may have. So the goal of the board itself was to become a flexible platform for system integrators, basically. So if you need a LoRaWAN gateway, you will buy a commercial LoRaWAN gateway. It will maybe have a built-in network server like ours do. But if you want to go somewhere beyond that, if you want to do some edge processing, if you want to deploy some other services on the gateway itself, then these gateways usually fall short. So the goal of the WisGate Connect is to have a powerful, flexible platform where you can deploy multiple radios, multiple services, multiple protocols, and manage it your own way, so to say. Okay. So the WisGate Connect is actually the commercial name of the RAK7391, which is this board. I think you can still see my camera. Attention. This board is a carrier board for the Raspberry Pi Compute Module 4. The Compute Module 4 is just like the Raspberry Pi 4, but without the peripherals and meant to be an industrial degree device. It's also compatible with the CM5 that just was released yesterday. So if you happen to get one in your hands, then you can use it with the RAK7391 with WisGate Connect. There are some of the new features in the CM5 that will not be available for the WisGate Connect because the pinout has changed somehow, but there are no incompatibilities, let's say. So you will not have a second HDMI, you will not have a second DSI, or the USB 3 on the CM5, but you will still have the USB 3 on the Connect. And then the board itself is a mini ITX form factor, which means that even though we also provide the enclosures, you can source standard enclosures your own, compatible with the Connect, with the RAK7391. So just summarizing a little bit, the Connect has the CM4 socket, pretty obvious where you connect the CM4 board. I'm not sure, can you see my camera too? Then we have 3 mini PCI slots, 1, 2, and 3 here. You have an M.2 slot on the back right here. The WisBlock slots here. You might know about the WisBlock ecosystem we have. You can also connect WisBlock I/O modules to the Connect. You have a Raspberry Pi slot here, so for Raspberry Pi heads with the standard pinout, so you can use any Raspberry Pi. And then you have the usuals like for camera and screens. You also have an I2C slot here, which is meant basically for the OLED screen that we have on the indoor gateways, but you can plug any other I2C device you want here. And you have a slot for a PoE module. So PoE is optional with the Connect. It's a module. You can buy it with or without it. And the PoE module is the one that you have in the screen, the RAK1963A. Which is an AT PoE module capable of up to 24 watts, which is enough for the Connect and pretty much anything you can plug to in, anything, I mean, you can still overpower it. And then you have several connectors for fans or for external devices that might need like extra power, like maybe an SD drive, something like that. On the outside, you have 1 gigabit Ethernet port, which is also PoE compatible. It's actually this one, right? A 2.5 gigabit Ethernet port. You have 2 USB 3, 1 USB 2 console pins, so you have direct access to the UART in the CM4. And then you have 2 power connectors, one which is a Phoenix connector. The board comes with a male part, so you can easily mount your own, and a standard jack connector 5.5 2.1 millimeters, and full size HDMI. So with this, you have like a mini PC maybe based on the CM4 with plenty of connectivity options, both wireless and wired. Inside you also have like an ROTC, so you can have a real-time clock running on the board. You have a temperature sensor, so you will have both the CM4 temperature, which is provided by the CM4 module, and the board temperature provided by the DHCP. You have a security element to store like keys, anything you can think of. It's open. We also use it to get the unique ID of the board, a fine controller, and 2 GPIO expanders and 1 ADC. These are meant especially for the WisBlock. Since the number of GPIOs in the CM4 is limited, we added a couple of GPIO expanders. One of them is for several things in the board itself, base slots, and the other one is exclusively for the 2 WisBlock modules, as well as the ADC, which is for the WisBlock modules. And then you have your USB hubs, so we can provide USB signals to different peripherals. How to power it? Like I said, we have actually 3 options too with it. We have the option to use a PoE hat. It has to be the one that we supply. It's not the standard card, let's say. And then you have 2 power connectors. The power connectors support 9 to 28 volts DC, and that's it. Yeah. Well, you will have the presentation, I guess. So I'm not going to go through the details of the power tree of the board, but there is the average power consumption of the board is actually less than 7 watts, between 5 and 7 watts. But the max power available is about 25 watts. Different peripherals have different budgets because they are plugged to different sources of power. So the power tree provides this kind of information. And the other feature that I want to talk about is that we do have a IC to monitor the power in. So whenever there is a power shortage, whatever there's no power supplied to the board has 3 super cups that are meant for dying gas functionality. They are able to hold the power of the board for about maybe a minute, which should be time enough to shut down any services, critical services, send alerts and notifications about, hey, I don't have power. And you will get that information through GPIO 16 in the CM4. So the CM4 GPIO 16 is connected to this IC that's monitoring the power in. So you get prompt information about the power supply. Not how much you're spending, but if there is or not power in. Then the 3 mini PCI slots, they are regular mini PCI slots. They follow the standards, but not all signals are available on all of them. This is because we are limited in the number of signals. So basically, you need to know that there's USB on all 3 of them. So you can connect USB devices or USB mini PCI cards on any of them. The first 2 is USB 2. The third is mini USB 3. Then you have SPI slots 1 and 2 because the CM4, same as the Raspberry Pi 4, only has 2 CS signals. So 1 and 2 for the first 2 mini PCI slots. You have your WART on the first one, PCI line on the third one. So even though all signals are available everywhere, you still have a lot of flexibility on how to combine them to meet your requirements. And finally, there is an M.2 slot. A word of caution here because we've received a lot of questions about this, and some people have chosen the wrong device for this. This is a B-keying M.2 slot. It was meant for connectivity like 5G modems, which is B-keying. I'm saying this because you can also plug an SSD, and some people are using SSDs on the Connect, but then you have to source an SSD that has a B-keying connector, which is, most of them are M keying, so they won't fit. It has to have B keying connector, and it has to be PCIe or NVMe, not SATA. So SATA drives will not work on the Connect. So B keying NVMe PCIe, okay? Not SATA. Aside from that, it will work. We actually, after we realized some people were having trouble sourcing this kind of SSDs because they are not common, you can buy them from us as well. We have a deal with a provider in China, and they can provide us with compatible SSDs, and you can buy that from us. Then, so the standard GPIO, you can have Raspberry Pi 4, CM4, that's available on the head connector. But you can use them all as I said. It's a standard pinout. The only thing is that some of these signals are also available on other peripherals on the Connect. So you have to be careful about not reusing the same signal in different places. For instance, so you have here a list. I'm not going to go through all of them. But if you're using SPI on a mini PCI slot, then that SPI CS will not be available, or it will be already used. I mean, it's the same signal you will have on the head, so you will not be able to use both of them. Same thing with the OR, the same thing with some GPIOs. Like I said, we are already using somewhere else. And then we have these GPIO expanders that I mentioned about. We have 2 of them, each is 16 channels. So we have 32 GPIOs, extra GPIOs. So inside the operating system, you can use libgpio to access them. This is beyond the scope of this talk, but you have here at the bottom a line on how to toggle one of these GPIOs using GPIO set, which is one of the utilities that come with libgpio. But basically, you have 2 extra chips for GPIOs, chip 2 and chip 3. GPIO chips 2, GPIO chip 3. And here you have the mapping of each signal that we have both on the mini PCI slots or M.2 slot, or even on board with LEDs, to control LEDs, and the GPIO 3 on the WisBlock modules. You can easily toggle them by mentioning what chip you want to use, chip 2 or chip 3, what signal, and equals the level you want to assign to it, like 1 for high, 0 for low. And then some compatible hardware that I wanted to mention. So on one side, we have hardware that's provided by us, or RAKwireless. The WisGate Connect is compatible with every mini PCIe concentrator we are selling at the moment. That even means like the RAK2247, which is an SX1301, but also the 83, 46, and the 48, which is the 2.4 gigahertz low concentrator. It's also compatible with the M.2 concentrators we have, and it's compatible with the Raspberry Pi Hut, the RAK2245, which I'm not sure now that if we are still selling it, but it is compatible. Even with the old RAK833. It is also compatible with the LTE module we provide. I would strongly recommend to use the EG95 version of the module instead of the BG96. But that's the one you can also buy from as an add-on when you are in the store looking for the Connect. We are providing this one. Then it's compatible with the PoE module. Yeah, of course, and with a bunch of WisBlock IO's modules that I will mention a little bit later. And then we also have third-party hardware that's compatible with it. There's a lot of hardware that can be compatible with it. We have just tested a few of them. We are also providing some of them on our store, but otherwise we have tested them and proved working with the Connect. That means from Wi-Fi 6, IoT, Wi-Fi Halo, Zigbee, Z-Waves, Thread, 5G, 4G, SSD drives like I mentioned before, and pretty much any Raspberry Pi Hut will work on the Connect with those safeguards you have to take into account, not be using same signals. Okay. And like I said, WisBlock modules. So the Connect has 2 WisBlock IO connectors. So WisBlock has different kinds of connectors for core modules, for sensors, for IO modules, and for power modules. These are for IO modules. They are meant specially, they were designed to house modules for industrial protocols like CAN bus, Modbus, corresponding like link bus, and also analog in-out, digital in-out, all this kind of stuff. Actually, we have tested, and you can find on our repositories on GitHub, you can find examples on how to use the Connect with these modules, the ones in the list here. But of course, you can also test new modules which have the same connector. If there is any question at any moment, just interrupt me. All right. And talking about WisBlock modules, we also have a couple of, so actually I can show you. So the WisBlock modules, if you know about them, they're like 35 millimeters long, which means that they are like in the picture here, out to the right of this slide, they are longer than, so you can see them poking out the enclosure, which might not be good enough depending on the use case where you want to deploy it, etc. So we also have the short profile modules, which are the M family of WisBlock IO modules. We also have 2 at the moment, which is the 801M and the 5802M. These are the same, the brothers of the 5801 and 5802, the same functionality, only in a short profile for 420 milliamps, and for RS4 to 5 Modbus. and you want to know how this feels. I have one of Connect here. So you can plug the mail parts, and I think it's clear enough. You can see that they are perfectly aligned to the surface of the enclosure. So that's pretty good. All right. So jumping into the RAKwireless. RAKwireless is the recommended OS for the Connect. It's based on the Raspberry Pi OS. So you will, yes. Anyone wanted to say something? No? Okay, pity. All right, so RAKwireless is a fork of the Raspberry Pi OS. So you will have all the utilities, the tools that you are used on the Raspberry Pi OS, especially Raspberry config to configure several aspects of the function. And we have added a few scripts to it, some services like Docker, for instance, and some drivers to make it compatible with the hardware on the Connect, or even the hardware that some people might use with the Connect. Of course, you can also use the Raspberry Pi OS, and it will, in the latest version of the Raspberry Pi OS, I think all the hardware in the Connect will work all right, because they added the last driver missing was the one for the 2.5 gigabit Ethernet port, but it's already built in the last version of Raspberry Pi OS. So if you want a lighter version of OS, you can use that one. If you want to have the full features that we provide, like a Raspberry CLI, which I will show shortly, or Docker by default without having to install it yourself, then you can use Raspberry Pi OS. The RAKwireless. To flash the RAKwireless on the Connect, you have to know which kind of CM4 you are using. If you're buying it from us, we are only providing CM4s with eMMC memory on board, which means that you don't need an SD card, which are the ones that we feel like are more sturdy and robust for industrial use cases. But if you have a CM4 Lite version, which are the ones without eMMC on board, so you will still need an SD card like a Raspberry Pi, you can still use it with the Connect. There is an SD slot on the bottom of the Connect. You can use to connect the SD card. And of course, if you are using a Lite version with an SD card, then you will flash the operating system same way you will do with Raspberry Pi. So you will pop up the card, connect it to a card reader, flash using Balena Edge, whatever, and you're good to go, and then put it back into the Connect. But if you're using an eMMC, it's a little bit more involved to flash the OS to the eMMC. Basically, you have to put the CM4 on flash mode, so to say. And you can do it in two different ways. There is a button. So let me show you the screen already. So here we have the power connector, and there is a button just next to the power connector. This is the flash button. So in order to flash the OS on the CM4, you have to press the button and power the board while holding the button pressed. This way, the CM4 will get into flash mode. And then you will have to use the Raspberry Pi boot tool that provides Raspberry Pi to flash. Maybe if there is time later, I can show you how to do it. Once you have the board in flash mode, you can use Balena Edge the same way. But then instead of having an SD card, you will need a USB cable connected to the Type-C USB connector here in between the USB and the Ethernet ports, and this is connected to your computer. In the minute you do this, the CM4 will pop up as an external drive on your computer, and you will be able to use Balena Edge or whatever tool you want to flash the OS on the CM4. By the way, there is another way to set the board into flash mode, not involving the button. Some people are having trouble with the button because you have to keep it hold by hold it pressed while connecting the power. The other way is if you have access to the PCB, there is a jumper set here. It's hard to see on the camera, I guess. But one of these jumpers is called eMMC flash. If you connect the jumper in this signal, then it's the same as pressing the button. So you can just connect the jumper, power the board, and flash the OS. Just remember to remove the jumper before rebooting the board. Otherwise, you will get into flash mode again after the reboot. Once you flash the board, then you different ways to use the Connect. So the Connect, RAKpi OS doesn't have a UI. It's like the Raspberry Pi OS Lite version. So it's only for, it's a server, let's say. It's not with the UI. You can install the UI afterwards if you want to, like you would on a regular Debian distribution. But then you have three different ways to access the board once you have flushed the operating system and reboot. One of them is to connect an HDMI and USB, and then you will have access to the board through the monitor, and you will have like a terminal, regular terminal. The other one is that if the operating system, when it boots, does not have a Ethernet connection, it will automatically build an access point. You can connect to the access point and set the credentials for your Wi-Fi router or whatever you want to do with it. You can connect to the board. And the other one is that if you have an Ethernet cable connected to the board and to your router, and your router has a DHCP service running, then it will get an IP from the router like any other device you can have in the office or at home, whatever. Problem is, how do you get the IP? Right? How do you know what IP this device is if you don't have a monitor, you don't have it? So it's the same thing as with a Raspberry Pi. You have different options. You can check your router, the one that has provided an IP to your CM4, to your Raspberry WisGate Connect, to see what IP it has sent to it. Some routers are easily to find this information than others. The other one is that the operating system has a host name, RAKwireless by default. So you can ping RAKwireless from .local and you will get the IP. And you can also do an ARP/A. -A. This will work both on Windows, Linux, Mac. So you will get a list of all the devices connected to your network. And if you do it before and after, then you will see what differences are. And the other way, it's not here, I forgot to add it to the slide, is that in the indoor enclosures like this one, you have an OLED screen, both on the aluminum enclosure and on the rack enclosure, you have an OLED screen. And the OLED screen provides some information about the device, like what services, what Docker services are running, what is the CPU load, the memory usage, and also what IPs the device has. So you can get the IP from the OLED screen easily, right? These will not work for the outdoor enclosures because the outdoor enclosures like this one, it doesn't have an OLED screen anywhere. So you will still need to use any of the other methods to find out the IP of the device. Once you have the IP, you can SSH into the device. That's a normal way for a server like a Raspberry Pi is to access to. The default login. So if you know about Raspberry Pi OS, you have to create a user now. From the latest versions, they changed the way to log in. With RAKwireless, we have kept a default user, which is RAKwireless. I'm not sure if it's RAK or RAKwireless. I'm not sure if this is wrong. I think it's RAK, not RAKwireless, sorry. So the default login is RAK, and the password is change me. Actually, on the first login, the OS will force you to change this password. So you will log in with RAK change me, and it will tell you, okay, the policy of the system is that you have to change the password now. What is your current password? Change me. And then you have to enter new password twice, and it will force you out. It will log you out. So you'll have to log in again using the user RAK and the new password that you set in order to get into the device and start working with it. Once you're in, you can create new users. So you can do whatever you want, but this is the procedure for the first login. So what can you do? Actually, I'm going to, instead of going through the slides here, I'm going to show you how the Connect looks like. So I have this board that I just showed you running by my side. I'm going to just simply RAKwireless. I'm cheating a little bit because I have my key in the board already. So doing SSH RAKwireless just logs me in, no trouble. It's easy if you want to have like a developing device like I do here. And it's also a good security policy for accessing remote devices as well, having a key and only be able to access through a public private key. Okay, so I'm inside the RAKwireless now, inside of WisGate Connect. So you have a little bit of information about the device already. And one of the things that you can do is that you can, so one of the things we wanted to do is to make easy for people to deploy services. The RAKwireless, I said it right. The RAKwireless does not come with any service installed by default, except for Docker. So you don't have, it's not a relevant gateway, it's not a standalone device, it's not an edge computing device, it's nothing. It's just the operating system and pretty much anything else. So if you want to run a LoRaWAN gateway in it, you have to deploy at least packet forwarder. So I'm going to show you how to do it here. Let me minimize this. So I'm not sure if you can see the screen right. Hopefully you can now. So we have this utility, RAKwireless CLI. CLI stands for Common Line Interface. And it looks like the Raspberry config too, because it's based on the same framework. But here you have the option to manage networks. You can also do it on RAKwireless, on Raspberry config, deploy services, or manage deploying services. So I'm going to go to deploy services. And then what we've done is that we created a tool that fetches services from a repo we maintain. This repo has a curated list of services you can run on the Connect with some sensible defaults already built in. So you have to do pretty much the minimum. What I'm going to do, so as you see, we have different stuff. We have from church stack, the thing stack, BT, Grafana, InfluxDB, a lot of things here, a lot of basic station. So if you want to run basic station gateway, you can do it with this. And what I'm going to do is the simplest one, which is the UDP packet forwarder. So this is the default for many gateways. You already know about it. If you select the UDP packet forwarder and if you select any of the others, you will have these two options, which is, okay, let's configure the environment variables if you want to. So change these sensible defaults we've defined and start the service. So I'm going to go here so you can take a look at what options you have. This depends on the service, of course. Every service will have its own variables. For the UDP packet forwarder, what is important is to set the band. This is for Europe. If you are in the US, if you are in other parts of the world, you will have to change it to one of the available ones. You can choose from here. I'm going to choose Europe again. By default, the gateway UI is well created based on the concentrator. So you will have a unique one for that concentrator. The interface, usually with the WisGate Connect, if you buy it if you source it with a LoRaWAN concentrator, that concentrator will be USB. So you'll have to go here and choose USB. But the one that I have on this one is SPI. So I've set it as SPI. It's a RAK 5146. So it's a RAK 5146 SPI for EU 868, what I have inside. And there are many options like REST GPIO on the first mini PCI slot is 17. That's something that you have in the slides before. The second one is 6, but the defaults will work for me. So I'm going to save them back and I'm going to just start the service. I confirm that I want to start it. And what it does, it downloads the image for the UDP packet forwarder. This is a Docker image and starts the service. And this is the output. So basically here you have the meaningful information is the gateway UI. So that I know that I have UI. And by default, I have not set, by default, it will connect to TDN. You can also choose another service or even a local chip stack or the things stack service. You can also configure it. If I go to list services, I have the UDP packet forwarder and I can check the logs and I can see that it's actually already working. And some of the settings here, like I said, it's connected to TTN. Okay. So the goal of the RAKwireless CLI is to simplify deploying services as much as possible. My recommendation is if you don't know anything about Docker, then go for RAKwireless CLI. If you know about Docker or you have some experience, then you maybe want to build your own Docker Compose file, for instance, and have your configuration already there and just deploy it whenever you want. But RAKwireless CLI will help you on these first steps or to deploy simple services or forget about that process. Okay, you can start the service and you can remove the service from within the RAKwireless CLI. It will take a little. Okay, I'm going to get out now and then I'm back into the prompt. Like I said, you can also use Docker directly. So I have the same UDP packet forwarder is exited because they started. But you can use Docker from the command as well. Now let me go back to the presentation to see where I am. Services, network connectivity. Okay, so as you see, there are some network options on the RAKwireless CLI too. RAKwireless uses Network Manager, which is the default network manager for Debian distributions now. Raspberry Pi OS comes with Network Manager as well. So you will, like I said before, you can use RAKwireless CLI to manage the networks, or you can just use NM CLI, which is Network Manager CLI, manage them. You have 3 SIM slots on the Connect. They are connected to mini PCI slots 2 and 3 and the Ender2 slot. If you're using the RAK 8213, which is the LTE module we provide, mind that the module itself has a SIM slot on the back, and it's usually connected, the modem is connected to that SIM slot. So you will have to set the SIM card there. You will have, if you need the SIM card to be accessible from outside the gateway, then you will need a special version of it. RAK 8213 that uses an external SIM slot instead of the built-in. And they are all nano SIM, and there is option also for eSIM if you want to. They are not mounted, so you will have to, if someone needs an eSIM chips on board, then we have this option as well. And like you saw in the list, we provide many different services you can easily deploy with RAKwireless CLI. And a few other things. So on 44, let's try to go fast. We are about to release WisGate Connect for IoT, which is basically WisGate Connect with a middle cross edge card for IoT. And the RAKwireless already has a script, which is IoT CLI. Everything is something CLI. To manage easily the middle makers, configure the connection, configure the firewall, and the host. You need to configure everything you need to do in order to make it work with the WisGate Connect. You can do it with the IoT CLI tool, and there is documentation on our website as well. And around the enclosures, we have, like I said, it's mini ITX, so you can use any standard enclosure if you want to. You will need a plate specifically. But we have the aluminum one, which is the one that I just shown you. It has an OLED screen. It has access to the different peripherals, external peripherals, and you can connect that to 6 SMA antennas. Then we have the rack version, the rack, not rack from us, but like a server rack. It's a 1U height, and it's not standard width, so you will need some kind of ears, which is common for this kind of devices. And otherwise, it's the same as the aluminum one. And then we have the outdoors enclosure, which is pretty much the same as with WisGate Edge gateways we have. WisGate Edge Pro, sorry. But this one doesn't have an OLED screen. And we have 2 different versions. I actually wanted to talk to you about this. So if someone needs an outdoors version of the WisGate Connect of the RAK 7391, especially if they want to have like certifications. We are finding trouble certifying this because it's so flexible. There are so many options. It's really hard to say. Instead, we have a new version, which is a RAK 7393, which is actually the one I have here. This one, like in the pictures, it still has a CM4, it still has mini PCI 3 mini PCI slot. It doesn't have WisBlock or Ender2 slots, but it does have Modbus by default, RS45 by default. And it's compatible with our battery solutions. So the battery plus solutions, you can plug a battery plus solar panel to it, and it will work fine. And also PoE. It has 2 connectors for N-type antennas. And on the back, you have the connector for the external power supply plus the RS485, so it's 4 lines. You have Ethernet with PoE, and then you have access to SIM card, to flash port, and everything you need to work with the board work with the device without having to open it up. So this one is the recommended version for outdoors instead of the one based on the RAK 7391. Okay, this is something new. We still don't have it on the web store, but we already have some devices and we are already shipping it to some customers.